Hey folks, how's it going? Welcome back to another great week of math. Here I am with another do now for course 1 CP, and this one is for Tuesday, May 26, 2020. So we're going to be here again as we've been doing for the past few days, right? We're going to be converting to standard form by expanding. Okay, we're going to be converting 2 times j plus 18 times j plus 12. And then we're going to be factoring q squared minus 2q minus 80, 3p squared minus 10p minus 13, and n squared minus 144. You can see right here the relative levels of difficulty that have been attributed to these. And I recommend that if after this video or even before this video, this is a concept where you're like, I have no clue what's going on at all, I really would recommend you check out my videos on how to do this stuff. I would recommend that first. 2, I would really highly recommend that you please get some additional practice. And 3, I would recommend you come to office hours, the weekly hangout, or a combination, because we're going to probably at least discuss this in one more hangout. But we're getting to the end of the year, so we would like to kind of teach 1 or 2 more additional important topics as we prepare to get you guys ready to transition into course 2. Okay, so please take a moment, pause the video, expand the first, factor these 3 down here, and then when you're ready, unpause, and you can see what I got. Okay. So converting to standard form. So this means that we need to use the box method. Miss Conity, if you're in B period, Miss Conity, and I'd be happy with her permission to share us the F period. She did show another way of doing some of these problems. I think it was the factoring ones. If you don't want to do it with the box method, you don't have to. Remember, this is fundamentally at the very fundamental level, this is just distribution. The box, what it does is it acts as a visual representation for distribution, because factoring is reverse distribution. So the box is useful because it can act in both capacities. It can help us distribute and undistribute, so to speak. So to find this, we're going to do the area of j times j, which is j squared. Here we have 18 times j, which is 18j. Here we have 12 times j, which is 12j. Here we have 18 times 12, and that would require a calculator. I would probably never ask you or expect you to do 18 times 12 in your head. Though if you want to know how to do that, I won't discourage you. Okay? Now, I'll plug this in and I'll get j squared plus 12, 12 plus 18. So that would be 30j plus 216. And then the last step is to distribute. And I get 2j squared plus 60j plus 412. I almost said 512. I think I was thinking 256, but it's 412. Okay, so 2j squared plus 60j plus 412. If this is something that's still feeling a little bit scary or uncomfortable for you, I really would recommend that you kind of rewind and take a look at some of this previous stuff, and then because I'm about to move on. All right, so now we need to go the other way, right? We have these 3 quadratics that need to be factored, that is, to be turned into intercept form. Again, and I'll try to share this with F period. There is the other strategy Miss Conity suggested, and you're encouraged to use that. The only thing is, just make sure that you know how to have a strategy that works for you. As long as you have one that works, that's fine with me. So remember, you always put your squared up in the top left and your number down in the bottom right. It's like solving a puzzle, right? And it just comes down to understanding the fundamentals of puzzles. If you think about it, a puzzle, if you've ever done one, well, a lot of people like to start with the borders, right? So the borders always go on the outside, right? They're borders because they always have one flat piece, and the corners, those always have the two flat pieces, right? So similarly, we can figure out some of our corners because we know the square will always go in the top left and the constant number will always go in the bottom right. And so now what we need to do is we need to figure out this. What is going to go on the top and the left? So first, I need this to be Q and this to be Q. So that Q times Q is Q squared. Now, I need to multiply two numbers to get negative 80. One will be a positive and one will be a negative because a positive times a negative is a negative. I also know they need to add to negative, right? They need to add to a negative 2. So the negative number is probably going to be further from 0 than the positive number. Again, these are things that are going to help me inform my decisions, right? So the goal is one combination of numbers that multiply to the constant will work. That's true of this, and of this. The multiply is the only thing that's always true. Some people are going to say multiply, add. I'm going to tell you again, do that at your own risk. But multiply will always work. So we need to figure out how am I going to multiply to get 80. So I could do 1 and 80. I could do 2 and 40. 3 doesn't go into 80 because the digits don't add up to a multiple of 3. 4 goes into 80 though, and it goes into 80 20 times. 5 goes into 80, and you know it goes in because if the last digit is a 0 or a 5, then 5 goes into it, and it's actually 80 divided by 5 is actually 16. 6 doesn't go into it because 3 doesn't go into it. 7 doesn't go into it. 8 will go into it, right? It's 8 times 10. 9, nope, 9's 81. And then 10, and once you get back to one of the ones on the other side, you know you're done. So one of these combinations is correct. The question is which one? Now, let's start by thinking about ones that are less likely to be it. 1 in 80 is very unlikely to be it, so we're probably not going to start here. 2 in 40 is unlikely to be it. 4 in 20, also unlikely to be it. So I'm going to actually start with the numbers 8 and 10. And as it turns out, if I make one of them negative 10 and the other positive 8, the numbers will multiply to negative 80, and that's true no matter which of these pairs you choose, right? Otherwise, you didn't choose a good pair. And this is going to be 8Q, and this is going to be negative 10Q. Now let's add them up, and notice they're equal to negative 2. If they weren't, you'd say, all right, well, you know what? So what? I got it wrong. Well, it's not wrong yet. I haven't submitted it. So I'll just see what I can do to help find the one that's right. All right, don't worry. It's like, look, this stuff is not easy. And this is a situation where, again, getting the wrong answer is okay because getting the wrong answer can help you get the right answer. As long as you're able to actually work your way through, add things up, and turn it into a reflective process where you ask yourself, why did I go wrong? How could I tweak this up and make it better? How can I change it? As long as you can engage in that kind of like mature, kind of like deep dialogue with yourself, then you got it. All right. And I think that is a strategy that's going to work no matter what kind of quadratic you deal with. Again, other people are going to tell you, they're going to tell you the different rules. I've heard there's one rule for if A is 1 and one rule for if it's not. To me, that doesn't make sense. I would rather you just use the box and try to use what you know about how numbers work to do a puzzle, because that works all the time. But again, as long as you have a strategy that works and gets you the right answer, you do whatever you want. Now moving on to this one. Now this one is a sample where A is more than 1. I sampled one from the website. So here's the problem, right? So we know that the 3p squared is always in the top left and the negative 13 is always in the bottom right. So notice though, there are no numbers that multiply to negative 13 and add to negative 10 because the only way to get 13 is 13 and 1, just as the only way to get 3 is 3 and 1. But what's actually cool is it helps us out a lot because then this needs to be 3p and this needs to be 1p because then 3 times 1 is 3 and p times p is p squared. Now I need to place 13 and 1 so that these add up to negative 10p. If I place the 13 here, it's going to get multiplied by 3. But if I place it here, it's going to get multiplied by 1, right? So the 13 would be 1. Here, the 13 would go with the 3. So this is why you can't just simply try to multiply to negative 13 and add to negative 10, because one of the numbers will be getting multiplied by 1 and the other will be getting multiplied by 3. So that kind of throws a wrench into things there. So what I'm going to do is this. I noticed that 3 times 13 is 39. That's way, way, way off. I'm never going to be able to get back to negative 10. So I'm going to do this. I'm going to put the 1 here, and I'm going to put the negative here, because then this becomes negative 13p, and this becomes 3p. Now you might ask, Mr. Murray, how did you figure that out? The answer is I basically just guessed, right? I said, look, I think negative 13 and 1, and if I had gotten it wrong, I would have changed my answer, right? So that's fine. And the other reason I'm able to do it is because in reality, I've been thinking about these problems a little bit longer than you. So I've built like intuition that if you give it a chance, you can also build and be really great at this stuff. It's just about, are you willing to give yourself the chance? If you are, you can master this stuff. You really can. All right. Lastly, I'm going to go to this one. Now, if you were at the Hangout or watch the Hangout video, which I definitely recommend you do, and I'll post it in today's lesson, you saw that we started to investigate this special case. Notice how there's no B value here. It's only an A value and a C value. And so we said, well, how can I multiply to negative 144, right? These are going to multiply to negative 144, but then these boxes, when you add, are going to cancel out each other, right? They've got to be the opposite of each other, because only opposites cancel out when you add them, right? You only have two numbers you can possibly add, and they've got to cancel each other. They've got to be opposites. 5 and negative 5, 6 and negative 6, 10 and negative 10, 20 and negative 20. Those are the only kinds of numbers that will cancel each other out in a situation where you know you're only going to be able to add two numbers. What that means is that this has to be a perfect square, because if you think about those numbers again, 5 times 5 is 25, 7 times 7 is 49, right? 10 times 10 is 100, 25 times 25 is 625. All of those numbers are perfect squares. So if you see a perfect square minus another perfect square with no b value there, this is called a difference because of the subtraction of squares, because the squares, n squared and 144, are the things that are being subtracted. Unfortunately, at this point, my perfect squares are still in my room, my classroom, so you guys can't see the list. But these are the kinds of special numbers that you'd be looking for as the constant. So 4, 9, 16, 25, 36, 49, 64, 81, 100, right? You can think about taking your favorite number and just multiplying it by itself, right? So these are some examples of those numbers. Now, in this case, it's 144, and I know that I have my n and my n. Now, I know that if I have negative 12 and positive 12, and it doesn't matter where the negative and the positive goes, this would become 12, this would become negative 12, and watch what happens. They cancel out because they're opposites. And all that's left is n squared minus 144. So I get n minus 12, n plus 12. And in general, this is the format it follows. If you ever have a squared minus b squared, it's always equal to a minus b times a plus b. Next year in course 2, you guys are going to learn what happens if I do a cubed minus b cubed. There's all kinds of difference rules like that. Actually, there's really only difference of squares and difference of cubes that we're going to learn. But in any case, this is a little pattern. Now, if you learn this pattern, and we'll talk more about that most likely today, if you learn this pattern, what's the advantage to you? The advantage is you factor the problem quicker. If you don't learn the pattern, are you doomed? No. You just set up a box or you use another method and you can solve it. But these patterns are cool things that we see happen with and that share this common thing. Whenever we see a square subtracted by another square, we can figure out the length and the width of the final solution. It's going to be a, or the area rather, it's going to be a minus b times a plus b. We can actually definitively figure that out. Okay, we can figure out what they're equal to. So that's a cool thing. Again, if you don't know it, it will if you know it, it will save you time. If you don't know it though, you still have a strategy. But hopefully you're able to get these three right. So we have for the expansion 2j squared plus 60j plus 412. We have for the conversion q minus 10, q plus 8, 3p minus 13, p plus 1, and n minus 12, n plus 12. Folks, thanks very much for watching. Please don't forget to make sure you're staying up to date on the material and to check today's lesson notes. Best of luck. Don't forget to love math, and I'll see you next time.